Hopefully you have your notes and your paper in front of you and we're ready to start talking about some experimental design. So, a couple of definitions to start you off. First, an observational study. This is a study where you observe outcomes without imposing any treatment. So basically you're just observing what's happening. Whereas an experiment, you actively impose some treatment in order to observe the response. This is a very typical multiple choice question on a test or on the AP exam, asking you to distinguish between an observational study and an experiment. And the main thing to look for is, in an experiment, there's always some treatment being imposed upon the subjects. If there's no treatment being imposed, then it's an observational study. If there's no treatment being imposed, then it's an experiment. You can count on this being a multiple choice question. So, I've developed a new rabbit food called Hippity Hop. Now, you may not realize that I love rabbits, and I have a rabbit at home, and I have developed this brand new rabbit food called Hippity Hop. I'm going to make a fortune. I'm going to stop teaching AP Stat. I'm going to go into the rabbit food business. So here are my claims. I claim that my Hippity Hop rabbit food makes fur soft and shiny. It increases the energy of your rabbits, and it provides 100% of daily vitamins and essential oils. Now, can I just make these claims? Now, I know I made this great rabbit food, and I want to market this, and I want people to buy it, but can I just go out and make these claims? No, I can't just make these claims. What do I need to do in order to make these claims? If I want to market this, I want you to ask yourself, what would Mr. Evans need to do if he wanted to go out and really do this? Well, let's think about this. He would need to do an experiment. I would need to go out and actually see whether these claims are valid or not. Who or what should I test this on? Well, should I test it on people? Should I test it on guinea pigs? Should I test it on dogs? No, I should test it on rabbits because this is it's rabbit food. And what do I test? Well, I'm going to test the type of food. I'm going to test my food compared to someone else's food. That leads us then into another definition called an experimental unit. The experimental unit is the single individual, the person, the animal, the plant, or the rabbit, in this case, to which the different treatments are being assigned. A factor is the explanatory variable, what's explaining the change, and the level is the specific value for the factor. Alright, so the factor would be the food, the level would be how much of the food, how often, how many times a day, all those good things. A response variable is what you measure. So in this case we're measuring, does it increase their energy, does it provide 100% of their vitamins, does it make their fur soft and shiny. A treatment is a specific experimental condition that's applied to the experimental units. Alright, so the treatment is the food or the no food. So I plan to test my new rabbit food. What are my experimental units? They're rabbits. What is my factor? The type of food. What's the response variable? How well they grow. Again, this is a very typical multiple choice, a series of multiple choice questions, making sure that you understand the different definitions. Alright, so you need to be aware of that. Hopefully you've written all these things down. Alright, so there's my bunny. I'm going to use my pet rabbit, Lucky. I'm going to give him Hippity Hop. And my claim is, well, Lucky's coat is shinier, he has more energy, therefore Hippity Hop must be a better rabbit food. Well, there's something wrong with this experiment that I just did. Hopefully you see it. I didn't have a control group. A control group is a group that is used to compare the factor against. It can be a placebo, which means you get no treatment at all, or you can compare the old food or the current item, a different current food. There's lots of different ways you can compare them, but you must have a control group in order to have an effective experiment. A placebo is a dummy treatment, a treatment that can have no physical side effects whatsoever. Okay, so I didn't have a control group, so I'm going to fix that. I'm going to have a new experiment. Thought it up. Here we go. We have old food, we have Hippity Hop. I'm going to use Lucky and my friend's rabbit. My next door neighbor, he has a rabbit called Flash. I'm going to give Lucky Hippity Hop. I'm going to give Flash the old rabbit food. There you go. Wow, Lucky's bigger, he's shinier, so Hippity Hop must be better. No, there's still something wrong. I can't do that. That doesn't work. Alright, okay, well, let's try this then. I'm going to go out and I'm going to catch a bunch of rabbits. The first 5 rabbits that I catch are going to get Hippity Hop food. The remaining 5 rabbits are going to get the old food Okay, so you got that? I'm a pretty good rabbit catcher. I'm pretty fast on my feet. I'm going to go out there. I'm going to catch a bunch of rabbits. First 5 that I catch will get the hippity hop. The next 5, they get the old food. Here we go. First 5. They all got the hippity hop. The next 5, they all got the old food. Okay, that looks pretty good. The hippity hop rabbits have scored higher, so it's the better food. Okay, something's still wrong with this. Does anyone see what's wrong with it? Well, let's think about this for a second. If we go back a slide, so we have a picture here. Look at the hippity hop rabbits. They're all fat. They were the first 5 that I caught. Well, if they were the first 5 that I caught, then the reason I caught them is because they were fat and slow. And the next 5 rabbits that I caught, well, they were the skinny, short, fast ones that were too fast for me to catch. So, is it okay for me to say that hippity hop is better? No, because the only rabbits I tested hippity hop were the fat, slow ones. And the old food, they were to the skinny ones. So, my experiment still is not good. Okay, so let's try this then. I'm going to number the rabbits from 1 to 10. So, randomly number them from 1 to 10. I'm going to place the numbers in a hat. I'm going to shuffle the hat all around. The first 5 numbers pulled from the hat will be the rabbits that get the hippity hop food. And so the first 5, 9, pull out 7, pull out 5, pull out 8, pull out 3. The remaining rabbits get the old food. So now I have a mixture of rabbits. Right? I have them all mixed up. Now, I evaluated the rabbits and found the rabbits eating hippity hop are better than the ones eating the old food. Well, once again, the problem with this experiment is I'm the one doing the evaluation. I really need to get an independent evaluator, someone who is not going to actually be making money off of this rabbit food, to do the evaluation. That leads us into something called blinding. Blinding is a method that's used so that the units do not know which treatment they are getting. We don't want the rabbits to know which method they're getting, and it doesn't really matter for rabbits, but for people it might make a difference. If people know they're getting some super duper brand new experimental drug, they may start thinking, wow, I'm feeling better because I'm getting this brand new super duper experimental drug, and their subconscious might make them start feeling better. So it's better if they don't know what they're getting. And then that leads us into something called double blinding. And double blinding is where neither the units nor the evaluator know which treatment a subject received. So the evaluator doesn't know either. Okay, so now let's apply this to our experiment. We have hippity hop rabbit food. Hippity hop rabbit food makes fur soft and shiny, and it increases energy for all types of rabbits. Well, I haven't really done that yet. I've only done it with one type of rabbit. If I want to make that claim for all types of rabbits, I need to test all types of rabbits. So you need to make sure that your subjects are representative of your population that you're interested in. So be very careful about making a claim like this. Or if you see something that makes a claim like this, ask yourself, really? Did they do that? Okay, so then now that we've kind of gone through our fanciful example of rabbit food, principles of experimental design. You have to control. So control of effects of extraneous variables on the response. You need a control group. You have control by comparing treatment groups to a control group. Replication of the experiment on many subjects to quantify the natural variation in the experiment. Every time you do an experiment, you're going to get slightly different results. That's natural variation. It just happens. If you do an experiment 100 times, you may get 100 slightly different results each time, just because the humidity is different, the subjects are different, the day of the week is different. I mean, who knows? You're going to get a little bit of variation each time. So you want to replicate the experiment many times on many subjects so that you can kind of take into account that natural variation. And then finally, it needs to be randomized. There must be some element of randomization. So when you're designing an experiment, and again, this is another question that you can count on having on a test, is designing an experiment and explaining how you would set up an experiment. Your experiment needs to have a control group, it needs to be replicable, and it needs to be randomized. The only way to show cause and effect is with a well-designed and well-controlled experiment. That is a very, very important phrase. Put a star next to that and make sure that you write that down. If you're trying to establish cause and effect, the only way to do that is with a well-designed, well-controlled experiment. Alright, so let's go through an example. A farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizer. 15 similar plots of land are planted with the same type of seed, but they're fertilized differently. At the end of the growing season, the mean yield from the sample plots are compared. The experimental units in this case are the plots of land. The factors are the type of fertilizer. The levels would be fertilizer types A, B, and C. The response variable is the yield of the crop, and then how many treatments? Well, you're going to have 3 different treatments because you have 3 different types of fertilizer. Okay, so example 2. Consumer group wants to test cake pans to see which one works the best. It's going to test aluminum, gas. Experimental design. So a couple of different, we're going to go through the different types of experimental designs now. First, you can have a completely randomized design. And this is where all experimental units are allocated at random among all the treatments. This is a picture of how to describe that. So you have an explanatory variable, then you have 3 different treatment groups, completely randomized, and then you have a response variable. So you randomly assign the different things to different treatments, and then you compare at the end. So for example, we have a bunch of pink and blue shiny smiley faces. So we randomly assign the experimental units to the different treatments. Alright, so we just randomly assign them, boom, 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 all the different treatments. This would be a completely randomized experiment. Alright, no pattern, nothing's going on, completely randomized. Another type is called a randomized block. A randomized block is where units are blocked into groups, homogeneous groups, and then they randomly assign them to treatments. So the first thing we do is we divide them into 2 groups, and then in each group we would randomly assign them to treatments. So group 1 would get split into 3 treatments, randomly split. Group 2 would get split, randomly split into 3 treatments, and then we would compare. So you would make sure that you're blocking on a variable that affects the response. So here's an example again with our smiley faces. So first thing we would do is we would divide them into homogeneous groups. So we're going to separate them into blues and pinks. Alright, so all the blues are coming over to the left, all the pinks are going over to the right. Then, once we've completely split them up, then we would randomly assign the experimental units to treatments. Alright, so then randomness, half of blue gets treatment A, half of blue gets treatment B. Half of pink gets treatment A, half of pink gets treatment B. That's an example of a randomized block design. Okay, that leads us then to another type of block design called matched pairs. Matched pairs is a special type of blocked design. So what you do is you take experimental units and you match them up according to similar characteristics, and then you randomly assign one to one treatment and the other automatically gets the second treatment. You can have each unit do both treatments in random order. That would be another option. The assignment of the treatments is dependent because Unit A is going to get one treatment, but then Unit B is going to get the opposite treatment. So Unit B is dependent upon Unit A. So back to our picture. So now notice the difference in this picture. We have some happy blues, some sad blues, and some neutral blues. And then we have some happy pinks and some sad pinks and some neutral pinks. So the first thing we're going to do is we're going to partner them up. We're going to pair the experimental units according to certain characteristics. So all the happy blues go together and the sad blues go together, and the happy pinks go together and the sad pinks go together. Right? So you see they're all partnered up. Then we're going to randomly pick one from each partnership and assign them to a treatment. So each unit, each happy blue, we pick one of the happy blues, it gets treatment A, and then the other would get treatment B. And that way we get an equal number in each one. This is an example of a matched pairs design. This is a very powerful experimental design, and it's one that gets used a lot. Alright, this is one way to do it. Another way is to have the individual unit do both treatments. So like a taste test. In a taste test, they would give both treatments. You get one subject.
That's all, folks.